weekly assignment 9, question number 1. So here in the question, they are saying in a part, so in the arithmetic progression minus 18, so arithmetic progression is given minus 18, minus 11, minus 4 and 3. So this is the arithmetic progression given. So what is the specialty in arithmetic progression? Between any two consecutive terms, the difference between the two terms is the same. So that is what we call as the common difference. So for that we use the symbol D. So how do you find the common difference between any two terms? So from the second term you subtract the previous term. So which means from if you select the first two terms, from minus 11 you have to subtract minus 18. So minus 11, this minus get multiplied and it becomes plus 18. So your common difference will be equal to 7. So in Roman number 1, they are asking you to find the 16th term, that means T16. So now you know the value of n. The value of n means they are asking for 16th term, so n is equal to 16. Common difference we found, common difference is equal to 7. So another thing we know, that is the first term. The first term is minus 18. Now what is the relationship between these things, these quantities? That is given by nth term formula for the arithmetic progression, that is equal to a plus n minus 1 into d. So what is a? So the first term we found it, that is minus 18 plus n minus 1. N is 16. 16 minus 1 into common difference. So common difference is equal to 7. This is equal to minus 18 plus. So when you simplify the bracket, it will be 15. 15 into 7. So what is 15 into 7? That is equals to 105. So 105 minus 18. So the answer will be equal to 87. So we found the 16th term of the arithmetic progression. In Roman number 2, they are asking you to find the sum of first 12 terms, which means they are asking you to find S12. So what are the things you know? You know the first term is equal to minus 18 and common difference is equal to 7 and n is equal to 12 because they are asking for sum of first 12 terms. So what is the relationship between these things? So that is given by n sum of first n terms formula for the arithmetic progression, that is equals to Sn equals n divided by 2, 2a plus n minus 1 d. So here you are finding S12. So n is equal to 12, 12 divided by 2 into 2a. So your first term is minus 18 plus n is 12. So 12 minus 1 into the common difference is equal to 7. So this is equal to 6 times 2 times minus 18, that is minus 36. Minus 36 plus 12 minus 1, 11. 11 into 7, 77. So this is equal to 6 times. So minus 36 plus 77, that is equal to 41. So 6 into 41, which is equals to 246. So sum of first 12 terms is equal to 246. First question, part B. So in part B, so in Roman number 1, they are saying show that there are two geometric progressions in which third term is 486. So it's a geometric progression. So they are saying third term is equal to 486 and fifth term is equals to 54. What do we have to show is that there are two geometric progressions. For there are to be two geometric progressions, either there should be, so in geometric progressions, you know the special property is they have a common ratio between two consecutive terms. So if you for example this 3, 9, 27, 81, in this example this is a geometric progression. How do you ensure that it is a geometric progression? If you take any two consecutive terms and find the ratio, or if you divide the second term by the first term, so that is 9 divided by 3, you will get 3. So if you divide the third term by the previous term, which is equals to 9, you will get 3. So when you divide each term by the previous term, you get the same value. That is what we call as the common ratio. So here common ratio is equals to 3. So here they have given you the third term and the fifth term, and you have to show that there are two geometric progressions. In order to do that, you have to show there are two values for common ratio, or there can be two values for the first term. So either you have to prove there are there are two common ratios so to first term. So let's start. So T3, you know, in geometric progression, in first term, nth term is given by Tn is given by a times r to the power n minus 1. So if you write this formula for this, it will be equal T3 is equal to a times r to the power 3 minus 1, which is equal to T3 equals a times r to the power 2. So this is your first equation. So if you write the same thing for the fifth term, it will be equal to T5 is equals to a times r to the power 5 minus 1, which gives you T5. You can, instead of T3, you can write 486 because T3 is directly given. Here instead of T5, you can write 54. So 54 is equals to a times r to the power 4. So this is your second equation. Now you have two equations and two unknown. You don't know the first term, you don't know the common ratio. How do you simplify this? Simultaneous equation. You are going to apply the theories you learned in simultaneous equations, and you are going to find the value of the first term and the common ratio. So here what you can see is, if you take these two equations and divide, a will cancel, right? So that is what we are going to do. So we are going to eliminate a first, then find r value. So I'm going to take the second one and divide that one by the first equation. So which will give you 486 divided by not 486, so 54 divided by 486, that is equals to a times r to the power 4 over a times r square. Now what happens? The first term a cancels, and r square get cancelled with, so you know the theory you learned in indices. So these two get subtracted from 4, so it will be r to the power 2. Now for 51, it's 1. For 486, it is equals to 9. How do you know that? So 54 times 10 is 540. So if you just subtract 54 from 540, you will get 486. So you know it's 9. So now you have 1 over 9 is equals to r square. Then you need to find the value of r. What you are going to do is, you are going to take square root on both sides. So when you take square root, plus or minus will come. So here r will be equal to, so you can apply the square root separately to 1 and 9. Square root of 1 is equal to 1, square root of 9 is equal to 3. So you get two values for r. R is equals to plus 1 over 3, or r is equal to minus 1 over 3. So then you can write there are two geometric progressions, because you have two values for the common ratio. So you can write since there are two values for r, there will be two geometric progressions. So we have shown there will be two geometric progressions. Now we are discussing first question B, Roman number 2. In that one, they are asking you to find they are asking you to write the first three terms of the each of the geometric progressions. So in Roman number 1, we proved there are two geometric progressions. How? So we found two values for r, that is plus or minus 1 over 3. So with this, we concluded there will be two geometric progressions. So these are the two simultaneous equations we formed in Roman number 1. Now in this question, they are asking you to write the first three terms. So here we know R well, so we need to find the first three terms. So the third term is given. So here third term is already given, that is equal to 486. So third term we already know. So you need to find the first term and the second term. So here we have the first term and we have R value. Then we can use it and find the R value. So 486. So that will be equal to A times, instead of R you can put either plus or minus. So two R values. So R will be either equal to plus 103 or R will be equal to minus 103. So let's say you put 103, just plus 103 square. Then you can apply square to both numerator and denominator. So that will be equal to 486 is equal to A times 1 over 9. Then you multiply both sides by 9. So A will be equal to 486 into 9. So that will be equal to 6 into 9, 54. So 9 into 8, 72. 72 with this 5, 77. Then 7 will come here. So 9 into 4, 36. 36 with this 7, that will be 43. So your first term will be equal to 4374 if you take R as equals to 103. Now let's say you put R is equal to minus 103. What will happen? You are taking a square, right? So it will be minus 103 square. So there also you will get the same answer, 1 over 9, which means the same first term. Now you found the first term, so it's time for you to find the second term. So T2, so you know Tn formula, that is equal to A times R to the power n minus 1. So you need to find T2. So T2 will be equal to A is equal to 4374 into, what is your R? You can either put plus 103 or minus 103. So let's say you put plus 103, then that will be to the power, so 2 minus 1. So which gives you 4374 into plus 103. So it's like dividing by 3. So you can divide by 3. It will be 1, 4, 5, 8. So T2 will be equal to 1458 when R is equals to plus 1 over 3. So when R is equal to minus 1 over 3, here you are substituting minus 1 over 3. So it will be minus 1 over 3 to the power 1, right? So minus 1 over 3 to the power 1. Then the answer will be, so here only the sign changes. So when R equals, so you can say when R equals minus 1 over 3, T2 will be equal to minus 1458, because only the sign changes. Then you can write the two first terms of the two geometric progressions. So when R is equals to plus 1 over 3, so the first term is 4374, the second term is equal to 1458, the third term, that is equal to 486. So when R is equal to minus 1 over 3, it will be 4374, and here minus 1458 and 486. So this concludes Roman number 2 of part B.